Now that we understand what function constructors are, we can talk for a moment in this conceptual aside about built-in function constructors in JavaScript. Function constructors that are just there already inside the JavaScript architecture and ready to use inside the JavaScript engine, and how you might use them. I have my console open here in Google Chrome running, and let's show some of the built-in function constructors that exist, meaning that there are just some functions and function prototypes that exist, that many of which you might have used already, perhaps even without realizing it. For example, I could say that some value is a new number, and then give it a number to initiate with, or even give it a string to convert it to a number. Something like that. What is this? Well, it's using the new operator. So this is a function constructor, and JavaScript even uses the convention of capitalizing the first letter of the word. So I've created a new number. If I hit enter and then output what a is, notice that a is not a number. It's not a primitive. It's an object, because function constructors create what? Objects. And it added a primitive value inside of it, 3. But because it's an object, there's a prototype. So there's a number.prototype, which is what all number objects will have access to. And it has some built-in methods like toPrecision or toFixed for doing math and conversion there on numbers. Interesting, right? So that means I can do a.toFixed, for example. See that? All right, let's try a different one. How about a equals new string? And I'll start it off with John. This is also a function constructor. And a dot has access to a whole bunch of methods of things that I can do with a string, because those methods don't actually live on a, but live on string.prototype, which is the function constructor's prototype property where this variable's prototype is pointing, right? So that's actually where these interesting things like index of, for example, and I give it a character and it tells me whether or not it's there, or I give it a value and it tells me whether or not it's there. Now, I did this on string.prototype, so it didn't find anything, but if I do it on a, then the this changes, and I can find O at position 1, 0, 1. See that? So the string isn't itself, though. If I hit enter here, notice that string is not a string, it's not a primitive. It's an object, and it has all of these properties and methods on it, and then inside of it, what's called boxed inside of it, is the primitive value itself. So these function constructors, these built-in function constructors, look like you're creating primitives, but you're not. You're actually creating objects that contain primitives and give them extra abilities. In some cases, JavaScript understands that you intend to look at an object and not a primitive. So I could do John.length. What happened is that the primitive is just a primitive. It doesn't have properties or methods, but the JavaScript engine boxed it inside of a string object, which has all these properties and methods, and then gave me access to it kind of automatically. Basically the same as going new string John, and then doing the .length on that. Make sense? So there are cases where the JavaScript engine wraps up the primitive in its object for you, just so you can use properties and methods you might want to. But anytime you see new, maybe a new date, takes a string inside the function constructor. This is just a function, and I called new, so I get an object back. And what is a? Well, a is an object, because when I hit dot, I have a whole bunch of features that the JavaScript engine provided on where? Where are all of these properties and methods actually living? They're not actually living on A. Where are they actually living? Well, this is the name of the function, right? So they're living on date.prototype. And that's where actually all those methods and properties live on. Make sense? So when I'm using these function constructors, you have to remember that you're actually creating objects. And it turns out that this can be somewhat useful, especially if you're building extra features in libraries or frameworks to tack on to these primitive values, or really any of the pre-existing values like arrays or objects or functions inside JavaScript. So if I go to my app.js file, let's say I want to add a feature to all strings in JavaScript. Well, we saw that JavaScript will box those strings, that it'll convert the primitive to the string object, which has a bunch of properties and methods on it for you. And that's pointing to a prototype where those properties and methods actually live. And there's nothing preventing me in JavaScript from adding on to them. So I can go string.prototype, which is where all string objects will point at for their prototype, where they'll look at when going down the prototype chain. And let's say I wanted to add a feature like is length greater than. And I'll pass a limit, and I'll return this. Now, what is this going to be pointing at? Well, if I have a string object, it'll be pointing at that string object because the JavaScript engine takes care of that when going down the prototype chain. Dot length is greater than limit, so it'll give me back true or false. So I could say, let's say console.log John dot is length greater than, and let's say 3. So what's going to happen? True. What just happened? Well, the primitive string was automatically converted to a string object generated by the string prototype function. This is a function that returns an object because I put a dot after. And I added a method to the prototype. So all strings instantly have access to this method. All strings everywhere. That's the power of prototypal inheritance. I've just enhanced the JavaScript programming language just like that. And many libraries and frameworks use this technique to add features, to add concepts and ideas and utilities. Now you have to know what you're doing. You have to be careful. You don't want to overwrite a pre-existing property or method. But you can very powerfully affect the language by understanding function constructors, the prototype property of a function constructor, and editing the prototype property of built-in function constructors. Make sense? Now, this worked because this string was converted to an object automatically. So can I do that with numbers? Let's say I want to take number, which is the built-in function constructor. It's just a function intended to be used with the new keyword, and I'll affect its prototype, so hopefully affecting all objects created with the number constructor. And let's call this is positive. And this will be a function that just says, is this greater than 0? How about that? So can I use that in the same way? Refresh. I'll do 3 dot is positive. Oh, error. Why? Well, because JavaScript, while it's nice enough to convert a string for me automatically, won't convert a number to an object automatically. However, if I did something like a equals new number, so I use that function constructor, meaning a's prototype will point at number.prototype, then I could do a.is positive. So this whole thing of built-in function constructors, it's neat, and you can add some abilities, especially to things like arrays or strings, pretty easily. But it gets a little dicey as you try to deal with primitives versus things that were created with the function constructors that look like primitives. This looks like it's a number. it's not a number. It's an object that wraps or boxes up a number and adds a bunch of features. So it can get confusing. We're going to talk in the next lesson about why this is dangerous for a moment, and why in general you shouldn't use function constructors, the built-in function constructors, for these primitive types, unless you have to, even though it is useful to add features in some cases. All right, let's move on.